This video is about mathematical modeling and variation. In this video, we will discuss models for direct variation, models for inverse variation, and models for combined variation, and models for joint variation. Direct variation. If a quantity y varies directly as x, then we write this as y equals to k times x, where k is the constant of variation and y increases as x increases and y decreases as x what decreases. Direct variation with powers. So if a quantity y varies directly as the nth power of x, then we can write this as y equal to k times x to the n, where for some constant k. Now n can be any number, n can be 2, n can be 1/2, n can be 3. Example 1. Find a mathematical model that represents this statement and determine the constant of proportionality. V varies directly as square of r, and V is 154 when r is 7. So V varies directly mean V equals to k times square of r, which is r square. Now we substitute V equal to 154 and r is 7. So this equation becomes 154 equals to k times 7 square. Now square this 7, so it will be 154 equal to 49k. Now we divide by 49, so you have 154 over 49 and 49k over 49. Simplify 49, cancel with 49 gives you k, and we can divide 7 by 154 gives you 22, and divide the 49 by 7 gives you 7. So k is 22 over 7. Now we write the model v equals to k square and substitute value of k equal to 22 over 7. So the model becomes v equals to 22 over 7 r squared. Inverse variation. If a quantity y varies inversely as x, then we write this as y equals to k over x for some constant k. So example 2, find a mathematical model that represents this statement and then determine the constant of proportionality. So the statement is h varies inversely as the square root of s. H is equal to 2 when s is equal to 25. So first we are going to translate this one. So h varies mean equal. So you can say right h equal and then k. Now word inversely means you're going to divide by the square root of s, and square root of s is like this one, square root of s. So the translation of this statement is h equal to k over square root of s. Now to find k, we're going to substitute h equal to 2 and s equal to 25 in this equation. So h becomes 2, k is k, and s becomes 25. So now we have 2 equals to k over square root of 25. While simplified square root of 25 is 5. So this becomes 2 equals to k over 5. Now to solve for k, we multiply both sides of each side by 5. So this becomes 5 times 2 equals to 5 times k over 5. Now we simplify each side. 5 times 2 is 10, and 5 and 5 cancel, so give you k. So k is 10. Now we substitute k is equal to 10 in this equation. So here that equation is h equal to k over square root of x. So when we substitute k is equal to 10, so this equation becomes h equals to 10 over square root of s, and that's the mathematical model. Combined variation involves both direct and inverse variations. So here's an example. If y varies directly as x and inversely as z, then we can write this situation as, so first write y varies we translate to k equal and put k and then directly mean k times x, inversely mean divide by z. So translation is y equal to k times x over z. Example 3. Find a mathematical model that represents the statement. Determine the constant of proportionality. P varies directly as x and inversely as the square of y. P equals to 28 over 3 when x is 42 and y equals to 9. So let's translate. P varies directly as x. So we write P equals to k times x. Inversely mean divide the square of y. Divide by y to the second power. And now we substitute P is equal to 28 over 9, x equal to 42, and y equals to 9 in the model. So the equation becomes 28 over 9 equals to k times 42 over 9 squared. We square the 9, so we can 28 over 9 equals to k times 42 over 81. Now you have to solve for k. So in order to get rid of 42 over 81, we multiply with the reciprocal of 42 over 81, which is 81 over 42 both sides. So now we have 81 times 42 times 28 over 9 equals to k times 42 over 81 times 81 times 42. We can cancel 81 with 81, 42 with 42, and we have a k on the right side. Now we can multiply 81 times 28 divided by 42 times 9. Put on this calculator and try to get k is equal to 6. And now we put k is equal to 6 in the original equation. P equals to k times x over y squared. So this equation becomes P equals to 6 times x over y squared. Joint variation. Joint variation occurs when a quantity varies directly as the product of two or more variables. So here is an example. If a quantity z varies as x and y, then we write this as z equals to k times x, y for some constant k. Remember, when there is no word directly in the statement, we will always assume directly. Example 4. Find a mathematical model that represents the statements f is jointly proportional to r and cube of s. F is equal to 4158, r equal to 11, and s is 3. So f is jointly proportional to r and cube of s. There is no word directly, there is no word inversely, so we'll assume directly and we write f equals k times r times s to the power 3. Now we substitute f equal to 4158, r equals to 11, s equal to 3. So this becomes 4158 equals k times 11, 3 cube. Now we simplify. 3 cube is 27 times 11 to 97. Okay, now we divide both sides by 297. So we have 4158 divided by 297. 297k divided by 297. Simplify, they cancel out, and if you divide using calculator, it gives you 14. So k is 14. Now we write the model f equals to k times rs cube and substitute K equal to 14. So this becomes F equal to 14 times R times S cubed. Example 5. If the state income tax varies directly as the gross income and the worker in that state has income tax deduction of $46.05 for the gross monthly income of $1,500. Find the state income tax of the worker whose monthly gross income is $6,000. First step is we're going to write the equation. So let's see. Let's say T is a state tax and I is the gross income. And it says the state tax varies directly as I, the gross income. So we can write T equals to K times I. Now we use the values of T equal to 4650 and I equals to 1500 to find K. So let's rewrite the model again. T equals to Ki. Substitute T equals to 46.05 and I is 1500. This equation becomes 46.05 equal to K times 1500. Solve for K, in other words, divide both sides by 1500. So this becomes 46.05 divided by 1500 equals K times 1500 or 1500. Can simplify 1500 cancel, it becomes K. Put this on the calculator, gives you 0.0307. Now again rewrite the model T is equal to Ki and substitute K 0.0307. So the model becomes T equals to 0.0307i. Now we answer the last step. Answer the problem question. Find the state income tax of a worker whose monthly gross income is $6,000. So the model is T is equal to 0.307i. Now we substitute I equal to 6,000. So the tax becomes 0.307 times 6,000, 184.20, and that's the state income tax, $184.20. Thanks for watching. Subscribe and comment, it's free.